have two vectors. Let's say we have vector u be equal to x1, y1. Then we have vector v be equal to x2, y2. Then we can add the two vectors. U plus v will be equal to, we add corresponding components. So x1, y1. Then we have x2, y2. So this will give us x1 plus x2. Then we have y1 plus y2. Then similarly, vector u minus vector v will give us x1 minus x2. Then we have y1 minus y2. Here is a work example for addition of vectors. So given that ED is equal to -4, -6, and DC is equal to -4, 5, find ED plus DC. So ED plus DC, ED plus DC will be equal to -4, -6, and plus -4, 5. So this will give us -4 minus 4. Then we have -6 plus 5. Negative plus -4 will give us -4 minus 4. So this will give us -8, that's -8, and -1 as a result. So geometrically, addition of vectors has a meaning. So we added vector ED, so from E to D, to vector DC, and we had -8, -1 as a result. Now starting from E, we move -8 in the, starting from E, we move 8 units in the -x direction. That's the meaning of -8. So we have 1, 2, 3, 4, 5, 6, 7, 8. Then we move 1 unit in the -y direction. So we are here. Hence, this is our vector. A vector EC. Vector EC is also having component -8, -1, meaning that vector EC is equal to the sum of vector ED and DC. So vector ED plus vector EC plus vector DC is giving us vector EC. So geometrically, the result That is the resultant vector. We call this the resultant vector. The resultant vector is a vector that is meeting the two vectors that are adding, which are following each other. So this vector is following this vector. In other words, they are all moving in the clockwise direction, and the resultant vector is moving in the anti-clockwise direction to meet them. And this brings us to a very important law called the triangular law of vector addition. So if you have a triangle A, B, C. So we have A, B, C, where vector AB and vector BC are following. Then they are meeting a third vector, which is the resultant. So we have AB plus vector BC being equal to AC. So notice how a vector is formed, or the relationship is established. The resultant vector has the initial point at the beginning of the first vector and the terminal point at the end of the second vector. So if you have PQ plus QR, then this vector will simplify to give us PR. So this will give us vector PR. We can use this to simplify geometric relationships or establish the relationship between geometric figures. Or we can use this to simplify vectors and also establish relationship between geometric figures. For instance, if you have vector P, Q plus vector Q, S, then plus vector SR. When you are asked to simplify this, we take it in pairs. So you take the first two, or you take the last two first. So let's do the first two first. So this will simplify to give us vector PS plus vector SR. Now this will also further simplify to give us vector PR. Or if you prefer to take the first two first, then we are going to have vector PQ plus vector QS, then plus vector SR. So we take the last two first. So this will simplify to give us vector QR. Then we have PQ. So PQ plus vector QR. And this also simplify to give us vector PR. Given that PQ is equal to 4,6, QR is 5,2, find PR. So we just seen that vector PQ plus vector QR will reduce to vector PR. So we just have to sub in and simplify. So we have 4, 6 plus 5, 2 being equal to vector PR. So our vector PR now will be equal to 9, 8. Given that CD is 4, next 6, 4, negative 5, and ED is equal to negative 4, 6, find ED minus CD. So vector ED minus CD will be equal to we have the ED to be negative 4, negative 6, minus then 4, negative 5. So this will result in negative 4 minus 4. Then we have negative 6 minus negative 5. And this will simplify to negative 8, negative 1. So in other words, we're just adding the negative of vector CD, which is DC, to ED. That's why we had the same result as in the previous one. So subtraction of vectors is just adding the negative of the vector to another vector. Position vectors.